Go ahead. Get some seats in the front. Good. Okay. Oh, all right. Welcome, everyone. It's great to be back. But it's great to be back. First up, I'd like to acknowledge the Gadigal people of the Aurora Nation, the traditional custodians of this land. Pay my respects to the elders past and stuff. CocoaHeads organisers, got Zach over here, Nikki over there at the back, and myself. If you have any questions in the next month, it also leads into code of conduct. If you are coming to CocoaHeads or you're interacting with us on Slack, Craig, sit down. I will. Sorry, Dad. Yeah, just Craig, just. Yeah, I know it's because of me. I understand. That all comes off to Zach or Nikki or myself. Huge shout out to Bilu. Thank you very much for having us. The food, the drinks, yeah. And looking into the future for next month, we're actually going to be, it's an exciting month. We've got WWDC. We're now going to move CocoaHeads back 1 week. And we're going to change the format a little bit. We're going to actually have 2 panels. The first one will be a community discussion. So if you'd like to be on that panel, we've had panels before and they've been really successful. And the slides aren't updated. There we go. And we've got some Apple engineers, some talks and a panel with Apple engineers. If you want to submit some questions for that, please. For next month, we have a charity auction. And so we've had some items donated, which with the premise that please give generously for that. And that's pretty much for the housekeeping. That's all that stuff. So you've done your chores, that's all done. I know we're not going to WWDC, so not getting pinned, but I have some here. So can anyone tell me the date that CocoaHeads will be next month?
23rd.
Week later than normal. And can anyone else tell me what today is other than Thursday and CocoaHeads?
Accessibility Day.
Okay, you get a pin. All right, you can't answer anymore. Yeah, so today is actually Global Accessibility Awareness Day. It's the 11th year that it's been running outside the US. And the whole purpose of this day is to get people talking, thinking, and learning about accessibility, which is why when we found out that CocoaHeads and GAAD were on the same day, we tried to put together a full accessibility lineup for you. So getting to that, we have tonight's schedule. So we have a lightning talk from Chris and Tony. They're going to be showing us some very cool. And then we'll have Broek. He's actually an ex-Apple accessibility engineer working on the Mac OS team. So he's going to be talking about voice and keyboard accessibility. And then we have Rob Whitaker, who actually wrote a book on mobile accessibility. If you haven't got this book, I recommend you get it. It's a great resource, and he might be giving one away. No pressure, Rob. Please give one away to the audience. And yeah, his talk titled Next Level iOS Accessibility. And then we'll have a short break, and then we'll get into what I think is the headline act for the evening, which is the one and only Sommer Panage. And yeah, she'll be talking about cognitive accessibility. And I'm very excited for this talk. I know when I was learning, she actually was at Apple. She was a Apple accessibility engineering manager. She worked on sound recognition. What else was there? Guided access, to name a couple. So it's really exciting to have Sommer talk as well. She's joining us from New York. So it's currently 4:40 a.m. there. So she'll be the last talk. And that's pretty much it. So let's get into the lightning talk. Come on, Tony and Chris.
While they're preparing that, can I just ask any fellow staff that are in the room, if you are using your laptop hypothetically to be torrenting something right now, can you stop? Something's using all the bandwidth in the Zoom room. Please kill it, whatever it is.
I'll stop downloading Xcode. Sorry, Ken.
Xcode right now. That would be very helpful.
And can we share the password?
Yes. Your screen. Password thing. You try to. And it's not come up with by a developer, so it's not a simple. This is always good with everyone watching. It's awesome.
You're in my house. My credit card.
Oh,
Gary.
Yep. That's good.
Yeah.
There we go.
Yep.
All right. Let's see. Now I'm going to display some dots. Let's see. Hold on. Stop.
Stop mirroring, is it still connected?
Yeah,
There we go.
yeah, all right.
Good.
It's my contribution to you.
All right, so now let's start this. The stuff on the outside. We should be able to. Hopefully this will throw up over there. Yeah, there we go. All right, how do we get these sticky notes up? Sorry guys, this is first time we've done this. Is anybody a keynote expert? You just need to get the speaker notes up.
There we are.
Thank you very
All
much.
right, cool.
Excellent.
All right.
A bit of a late start, but I think we're good to go.
Oh, stop touching things, Chris.
All right. I'm normally good with computers.
Welcome, everyone. Thanks for coming along. We are really excited to be here tonight. I'm Tony. I'm Chris. We both work on Reveal at Itty Bitty Apps. Who in the audience knows of or has used Reveal in their day-to-day work? At least 2 or 3 people. Great. All right. So Reveal is a tool to help you debug your app's layout. We built it about 10 years ago. In that time, Reveal has improved the workflow of thousands of developers, and we estimate it saved years worth of developers' time. We've got competitors now, including Apple's Xcode View Debugger, which we take as both a tremendous compliment and confirmation that we're doing something right. It's a tool that if you come and ask anybody on our team, it really is the best at what it does. So we built Reveal at Itty Bitty Apps because we needed it, right? We're a consultancy, we go out, we do work with clients. We found a massive hole in our development flow. So we built this thing because we wanted it to exist. That same desire to build better apps faster is why we're here tonight. I'll give you a few stats now. Given that it's Global Accessibility Awareness Day, the theme of our presentation is obviously along those lines. I'm sure most of us are aware of some of these statistics, but roughly 15% of the world's population experiences some form of disability. That's a massive, massive number. According to Vision Australia, in Australia alone, there are currently about 360,000 people who are blind or have low vision. This is projected to grow to about 570,000 by the year 2030. So it's not a problem, it's going to get smaller. Roughly 8.5% of all Australians have some form of colour vision deficiency. In research published by Apple in May 2021, 94% of the surveyed mobile apps had at least one screen that wasn't properly accessible. It doesn't take much to render a screen unusable for a subset of your users. And I think everybody who's worked on accessibility in their apps knows that those regressions are frequent. When we're changing the layout of things, it happens often. Chris, what are we going to do about it?
Well, we're introducing workspaces to Reveal. So the Reveal that you know now is now Reveal's layout workspace. And its new accessibility workspace will give you the tools to inspect, experience, and verify that your app is accessible to all your users. And we spent the better part of last year figuring out what we wanted to build, and we spent all of this year building it, and now we're ready to share it with you. So without further ado, let's see. I should have gotten this set back to my internet.
We can give you a brief demo of the.
Yeah. So let's see. I'm just going to move it into this side, isn't it? There we go. I should be mirroring now, shouldn't I? Because this is going to be awkward. Let's see. Sorry, guys. There we go. Yes, now. Right, can everybody see this? So, yeah. What you're seeing now is the layout workspace of Reveal. This is the Swift UI app, so the UI kit being rendered out isn't particularly useful to you. But let's move to the accessibility workspace. Now, the accessibility workspace is the voiceover mode here. The navigator on the left-hand side will show you all the elements on the screen as they will be read out by VoiceOver. This lets you very quickly see when there's good opportunities for grouping elements. You can just have a quick look over on this screen here. If we turn on screen curtain, you can see that there are a number of groupings on this screen of accessibility elements that are separate elements to VoiceOver. And for example, this cluster here and this here and this here, and even each of these rows, you could very easily do it being grouped together. If you look at, for instance, and this is a contrived example app that one of our devs, James, has created for us, and I think it's awesome. We switch to just showing the image tabs here. Image descriptions furnished by SF symbols to describe the type of weather you're seeing that day, beyond the temperatures. Now, this is pretty clever, but at a certain point, you get to rainy weather, which becomes humidity.fill, and sunny weather that becomes brightness higher.image. This isn't probably what you want. Now, there's other things we can do too. We can switch to voice control mode. And on the screen, you can see that the only user interactable elements through voice control are the 3 tabs down at the bottom. Now, switching into our third mode, the Web Content Accessibility Guideline contrast mode, we can see that there's a bit of a contrast problem going on this screen. The nighttime temperatures at a certain point fall below the AA threshold because of the gradient background that's being used on the screen. Contrast results are an approximation done by analyzing the pixels in that region of the image. And you can see here we have a coverage of 94% of the pixels are either of these 2 colors. This also gives you the text information and the parts of the guidelines that you aren't meeting, which is good. You can also see that the contrast here for the inactive tab bar elements is very, very low. Let's see, and switching now to a different scenario in our sample app. You can see here a kind of GitHub-y scenario. And this is a very, very text-heavy UI, also built in Swift UI. If you filter by headers, you can see that there's 2 headers here. And this is a good thing because a very text-heavy screen is hard and or slow to navigate if there aren't any headers. But if we just look at the grouping of elements here, it's pretty clear. Again, let's go back to screen curtain, that beyond these elements that are vended by SwiftUI's lists and grouped together into semantic views, all of these other custom views here could also stand to be grouped together. If you look at the indicator here, it will tell you a lot of useful, the inspector will tell you a lot of useful information about each of these elements, including their traits, their frames, their activation points, custom paths, if they have them. They'll also be rendered in the canvas. Now, let's turn off that one, and let's talk a little bit about the contrast mode we can do here for deuteranobs who have a red-green form of color blindness. The very common use of red and green to indicate semantically progress, success, failure, and all that will lead to pretty awkward situations when you can't really discriminate between the 2. And if you now want to move to the contrast mode, you can see that the colors being used to analyze the contrast now are the colors that are being perceived in this moment. One interesting thing you'll see here is when you, let's see, I'll go into contrast mode now and I'll turn off the affected regions and then switch to blue cone monochromacy, which is a rare form of color blindness that essentially makes you monochromat with primarily night vision. Doing that will render anything that's blue almost invisible. This is an edge case, but we're programmers. We like edge cases. And then finally, moving to our last scenario. Let's see, let me just put the lag in. You can see this in Reveal's layout workspace, that it is built in UIKit. It has image button, which is a custom subclass. But then now moving into the accessibility workspace, we can see that there are certain elements on the screen that are conspicuously absent from VoiceOver. The image button, and if we look down here, we can see that the frame of this button is also kind of suspicious looking. If you go in here, we can see that it has the static text trait. So it's just a UI label of a custom view, which is interactive, that isn't exposed to VoiceOver. If you look at voice control, we can see that still it's only the tabs that you can interact with. And this is because anything that would be interactable here is just invisible to VoiceOver. Going into contrast mode, we can see something interesting. The cool background graphic is lowering the contrast of the text where they overlap. And since this is a UIKit-driven interface, we can now switch back to our layout workspace. And we can use one of the cool things that Reveal lets us do, which is to modify things at runtime. We can find the image, then we can lower the alpha to 10%, and then switch back. And now it's fine. This is Reveal's new accessibility workspace. Let's switch back to the presentation now, I'm sorry. Okay, drag this guy. Right. That was what just happened.
It's pretty cool, huh?
Yes,
I hope you can see that what we've built here is something that's incredibly useful, in terms of verifying what's going on in your app live. It's what's being shown to users on screen. Look, alongside all those features that Chris just showed you, there's a couple of other things I wanted to call out tonight. One of them was that Reveal already had the functionality to save a snapshot of your view hierarchy to disk so you could share it with other people. It also now includes that accessibility information. So you can save that out and hand that document to somebody else who has Reveal, and they can then go and inspect it and see those problems for themselves live at runtime. We've also added the ability to save out nicely formatted images. Not everybody has Reveal. We recognise that. But what we want to do is make it easy for you to point out to your design team, to your QA team, to the other developers in your team what's not working. And these, you can see up here on screen, these are just a couple of little samples of what it exports. It gives you the settings, what you've used to get it out, and allows you to pass them around. They're just PNGs. They've got a bit of metadata, a bit of XF info in them to keep them useful, but really useful stuff for sharing what's not going right. So let's do a really brief recap. That is the ability to quickly verify contrast of your app against the current WCAG guidelines. We realise there are new ones coming, but we're against the ones that are there. We now let you inspect the VoiceOver UI of your app far faster than you've been able to in the past. I hope you can see that. Anybody who's worked with Apple's Accessibility Inspect knows it's a bit of a labour to get in there and actually inspect everything and get through what's in your UI. This is instant and it's up there all at once. Reveal now lets you see how your UI will look to people with many common colour vision deficiencies, and dig into the details of what you've implemented, including some of the newer technologies like AX custom content and the new UI accessibility custom actions as well. So it's pretty comprehensive. So we're here on Global Accessibility Awareness Day with a tool that we hope will dramatically speed up your accessibility testing. We want you to use it. We're planning to release it in the next week. We want you to talk to us. We want you to tell us how you're using it. And we want us to tell you how you want to use it. This is just the very first step that we're taking. There's so many different places we could take this, but we want your input. So thank you. I hope that's...
Do you have any questions about that? Have you used your new accessibility inspector on your own app?
Well, no, because Reveal does not support inspecting AppKit apps. So
There you go. Because I was wondering about the blue button that you're using when you've gone into accessibility mode on the dark grey background.
standard system control, Craig.
Speak to Apple.
Yes.
Oh shit. Yeah, by the radar, don't.
Interestingly, the little tidbit about the WK colour guidelines that we're using there is that Apple's own colouring, the secondary label colours, are actually called out as being, they don't pass that. So there are things in here where we give you the tools to inspect it, but it's up to you to interpret those and how they work for your app.
It's more if you have to abide by the standards, then it has to meet that standard. Obviously, it will easily tell you when you have a significant problem as well, because a lot of apps do that.
Does it consider the text size?
Yes, it does. Where available, it will consider the text size and weight.
Apple's accessibility inspector sometimes differs from VoiceOver on device. Does Reveal's stuff to do with VoiceOver have any sort of similar considerations that need to be taken into account?
We've covered a few edge cases, but I'm sure that there's going to be plenty, especially as new versions of iOS come out. There's going to be movement that we'll have to follow. But it's the same job that we do with the Reveal as well, keeping up to date with the APIs. So yes, but probably maybe not in some cases. As best we can, I guess is the answer we can give to that.
Awesome. Thank you.
He's on the call, so he'll answer questions at the end, but it's just pre-recorded. So let's get started. Hopefully, hear this.
Good night, everyone. Welcome to this presentation, everyone. Good morning, good afternoon, good evening, or even good night, everyone.
Well, that's going to work airplane. Video.
Accessibility is for me.
You play?
Yeah.
It's not even. That's airplane.
Yeah.
Don't know, trying to play a video via Zoom is going to work well, man, to be honest. More Zoom.
That's how deleted.
Yeah. Zoom.
Okay.
It's recorded, man.
Oh, no.
Is there settings on the system preferences whether the volume is connected to the
Yeah, it's
TV
an
or
audio connected
output.
to.
The audio.
Zoom.
doesn't make sense that volume there is. Yeah.
And I'll click on the volume thing at the top. No, the volume one. Oh, the volume one, the first one.
I'm
Alt-
very good with trackpad.
Oh my God.
How many of these issues?
I'm output, go to output.
I think this might be how non-developers felt at the start.
Use stuff. It's the one page.
I think I've seen this one.
Right.
Oh yeah, it's like,
Audio is definitely working.
Bing, 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 bing.
Good morning, good afternoon, good evening, or even good night, everyone. Welcome to this presentation called No Touchscreen Required. I'm going to talk a bunch about voice and keyboard accessibility, where it's a little awkward that my voice isn't that great at the moment, but we'll get through it anyway. And thank you so much for Aaron for inviting me to this CocoaHeads. And super happy to share the stage with Sommer and Rob later. So we have a specially themed accessibility CocoaHeads here, and that's not just because. That's because today is a very special day, especially to us in the accessibility community. And Accessibility Awareness Day. And accessibility is something I care a lot about, and why I strive to make the products I work on accessible and share the knowledge that I have about accessibility. And that's why I accepted this invite, and why I'm always happy to learn from others and share this knowledge that I have. So that's what we're going to do today, and there's going to be a lot more in the other presentations as well. A quick introduction on myself. My name is Bas. Work on iOS, I work on accessibility and some more stuff at WeTransfer, which is a file transfer service, as you might have guessed, or maybe you even know it and have used it. Previously, I worked on the macOS accessibility team on Voiceover at Apple. I'm not sure if that was on your bingo card for today, and this was great, right? In the sense that I learned a lot, and things about the inner workings of Voiceover made a big change to macOS, and I got to know a whole great bunch of people that work on accessibility, but also beyond accessibility at Apple. I've also written a chapter for the Swift for Good Volume 1 book, which came out a few years ago now and was a project organized by no one other than Paul Hudson. It is a compilation of chapters about various topics related to Swift, and so I wrote about accessibility, and all of the copies that were sold, all of them digital, all of the revenue went to charity. And so this was a fantastic project, and I would definitely recommend you check out the book after. And so before we dive into the actual content about making an accessible app for voice and keyboard, I want to stand still at the reason why we're doing this. I bet a few of us have worked on accessibility, have tried to improve accessibility in apps, and have run into issues where other people are asking questions, and valid questions. Why should we invest in this? And I think a lot of that comes from a lack of knowledge about the topic, right? But they seem to be fair questions. And sure, it seems maybe obvious in hindsight to say is the right thing to do, but it really is the right thing to do. It can be your neighbor, it can be your friend, it can be anyone that just will not be able to use your app or your product without investing into accessibility, right? Imagine that you can't listen to your music, or that you can't watch TV, or that you can't keep up with friends, right? And keep in touch with your family and keep in touch with your loved ones because the app is not accessible. And so I think it's always this kind of an eye-opener when you show the power of accessibility and really make sure that people can understand like what it is like to not have this opportunity to really show why we need to do this and why it's the right thing to do. And hopefully this presentation today will also give you some ideas of how you can do that. Obviously, if only it were that easy and just do the right thing and we're there. It's definitely not a straightforward process to make your app accessible, in the sense that the APIs and the code you need to write are most of the time relatively straightforward, but understanding how to make your app properly accessible and understand how users relying on assistive technologies like use your app and how their experience can be improved, that is definitely not as straightforward. But getting a lot of it, like putting in a bunch of effort and wanting to get there, that's going to be your first step for sure. So definitely do not hesitate to go and try to make your app more accessible, and don't feel like you have to be an expert or take a course or whatever. Go for it and learn and learn and learn and ask a lot of questions. And speaking about questions, definitely also make a note if you have any questions during this presentation, and I would love to talk about them and discuss them and possibly answer them as well after the presentation, or even after that on Twitter. To set this whole thing up and go from an app that is not so much accessible or hasn't taken care of any specific accessibility needs to making it accessible for voice and keyboard, let's talk about the quote-unquote evolution of accessibility on Apple platforms. And this is all the things that are available on Apple platforms, or at least a whole bunch of them, and how they work together. So very much a fundamental of accessibility on Apple platforms comes in the form of VoiceOver, which is Apple's screen reader. And then on top of that, you have switch control as well, which builds on top of VoiceOver in the sense that you can use a switch. So that could be a single input to navigate your screen. And for that, you use the labels and whatever we'll set up for VoiceOver, as we'll see in a minute. And then in 2019, Apple introduced voice control, which instead of the screen reading out to you what is on there, you can read out what you see on the screen and activate it. So they might feel pretty similar, and a lot of that work for VoiceOver and switch control will get you most of the way to voice control. But there's still a few tricks and things lying under the carpet that we'll take a look at in a while. And then the newest big accessibility technology on Apple platforms is something called full keyboard access. It's maybe a bit less of a fancy name, but so full keyboard access allows you, as the name suggests, to access your device completely by just using your keyboard. And we'll take a look at how that builds upon VoiceOver, upon voice control, and how that can allow another way of interacting with your devices for a great experience. And so these are bigger technologies when we talk about assistive technologies, but that's not everything. And this slide will definitely also not cover everything, but I do want to point out a few other things. Think about Zoom, think about dynamic type, which is definitely a big one as well that you definitely want to look into. But for the purpose of this presentation, we'll focus on VoiceOver, voice control, and full keyboard access. we have reduced motion, etc., etc. And on top of that, we even have things like dark mode and backtap, Siri, and even haptics that might not even feel like assistive technologies, but can really help certain people. And especially for me, dark mode is a very big thing to cause less strain on my eyes. So definitely also take these into account when building your apps. And so kind of what I've been talking about is that there's these two separate layers of accessibility. On the one hand, you have VoiceOver, that is a screen reader, and then on the other hand, you have voice control and full keyboard access that are user input. And as I mentioned before, there's some slight differences between the two in terms of how we built for it, and we're going to take a look at that soon. And to start off this part 1 of 3, we'll start with Act 1, which is VoiceOver. And so for VoiceOver, I want to give a very brief overview of some of the API that is involved in making your app more accessible with VoiceOver. We'll definitely not be covering everything. I'm sure that Rob will tell you a bunch more. Sommer will tell you a bunch more, but I want to set this up so that we can make our app accessible for, VoiceOver in a minute and also full keyboard access, and this will be a good start. And definitely these parts of VoiceOver will be crucial to providing a great voice control as well as full keyboard access experience. So we have 4 variables here: accessibility label, accessibility traits, accessibility value, and accessibility hint. And if we're thinking about one accessibility element, so this is one element a user can navigate to with VoiceOver, these elements are going to have most of these variables explicitly set. And to give you an example, let's go through a slider for a music app. So here we have the accessibility label being volume. We have the traits set to adjustable, and we'll get to that in a moment. We'll have the value set to 56% in this case, and we have the accessibility hint saying swipe up or down to adjust. So this might read out to VoiceOver as something like volume 56% adjustable, swipe up or down to adjust. And I want to definitely make a note here, whilst the accessibility hints might be really nice when you start building accessible apps, and you might want to add them everywhere, and you probably should consider adding them in a bunch of places. Note that these can be turned off by the user, so you do not want to put any critical information in them that will prevent a user that has turned them off from actually interacting with your element. And then, we've all done UIKit. It's 2022. We should cover some SwiftUI. Here we have some updates to the API. We have slight updates to accessibility label. Then we have the adjustable action, which is really interesting because here we are not setting a trait, but in SwiftUI, you actually set an adjustable action for instead of this adjustable trait, where we directly handle that action, which in UIKit you would have to do separately for custom controls especially. In the accessibility value, we set the value to 50%, so we've turned down the volume a little bit, and then we set the accessibility hint as well. And it's these kind of things like the adjustable action that make accessibility on SwiftUI really cool, because the team working on SwiftUI and working on accessibility in SwiftUI has definitely thought about, hey, what are the things that are awkward in the API or hard to explain, and how can we improve that? And I love that they have made these kind of relatively drastic changes that are relatively opinionated, but I think really help developers understand how things are implemented, how things work, and ultimately making it easier to make an accessible app, which is obviously really, really cool. All right, so now that we've talked a bit about VoiceOver, I want to give an example of VoiceOver being used in an app. Well, not just any app, but the WeTransfer app that I'm working on. And one thing I want you to do before we start this video, pay attention to how we navigate it, what you're observing, because soon we'll show a different demo, which will greatly help to have paid attention to this first one.
Account menu button. Sent heading. Omega Speed Master button, more content available. Yes. Sent as link. 3.4 megabytes. Size. The 16th of May, 2022. Transfer date. In 6 days. Expires. Omega Speed Master. Transfer name. Omega. Double tap to dismiss pop-up window button. Close button. Select button. Sent as link 0 times. Omega Speed Master. 1 file. 3.4 megabytes. Sent 46 seconds ago. Transfer expires in 6 days. File. img_9089 JPEG button. Image. More content available. File. img_back button. share button. Button. Image. Jewelry. Watch.
So now that we've seen this first video and have a bit of an idea of how, adding proper labels, etc., can really help navigate the app, let's take a look at this again, but on what we would call quote-unquote normal speed, and you will see what that is in a minute, and something called screen curtain.
Account menu button. Screen curtain on. Sent heading. Omega Speed Master button. More content available. Omega Speed Master. Double tap to dismiss pop-up window button. Close button. Select button. Sent as link. Omega Speed Master. 1 file. 3.4 megabytes. Sent 3 minutes ago. Transfer expires in 6 days. Button. File. img_9089 JPEG. Button. Image. More content available. img_9089 JPEG. Button. Image. Jewelry. Watch.
All right, that was quite a bit. Let's go into what we're calling Act 2, voice control, and take a step back and see, hey, great, we have made some improvements for VoiceOver. How can we build on top of this to make sure that we can also have a great input experience where we can talk to our device with our voice and activate certain elements that way. And to start, as we started for VoiceOver, let's take a look at the API that we're going to be dealing with. And in UIKit, this is going to be accessibility user input labels. And I don't know of anybody watching or in the room that has not worked with accessibility user input labels, so that has any idea what this might be about or how this might work. But what I first thought when I saw this and when it was introduced was, what? I don't understand how this works. Why is this API the way it is? And so to learn about it, let's take a look at its documentation. And this is a lot of text, so let's zoom in on one particular bit. Use this property when the accessibility label isn't appropriate for dictated or typed input. And so if we go back and think about the two ways of accessibility, one being the screen reader and the other being input, this is about this dictated or typed input. And you might still be wondering, okay, what is different about those? Well, let me tell you. We might have an element in our app, and not just might, we actually have this in the WeTransfer app, and it says tap to copy link. But then if we're using voice control, we're going to have to say tap to copy link, which is really awkward and confusing. So what we want is to use this accessibility user input labels and improve this. And so making it copy link as its user input label allows us to say tap copy link. That's a lot better. Let's take a look at another example. As some of you might know, I'm a big fan of watches, and there's been an article on this website, and it's titled, "It's Complicated, Inside an E-lange Zone Split Seconds Chronograph." That's a lot of words. Tap, "It's complicated, inside an E-lange Zone Split Seconds Chronograph." And then maybe it might not recognize what you said, which is super awkward. Although, to be fair, most of the time it does. And one thing that is really cool is you can say part of a phrase and it will still try to match what you said with like a longer label. But we can improve this. Let's take a look at what that looks like. We can add an accessibility user input label that is called article. And so we might have some duplicates, but when we say tap article, we'll see these numbers on the screen, and then we can say 1. So this is an alternate input where we could still match the whole title of this article, but there's this alternate way of accessing the element, which is a lot easier. All right, so to go back to the API and to the code, in UIKit, we would have this copy link button with a label of saying tap to copy link. And, you know, ideally, these are all wrapped in NS localized strings and localized, and you should definitely localize these, but for the presentation, I've just made them plain strings. And so we have the accessibility user input labels that is not just copy link, but also copy. And so giving these alternatives, great, because sure, we can show names of all of these elements and users can read out, you know, what the activation for this element is, but giving multiple options makes it a lot smoother of an experience. And as we'll see in a bit, this will also benefit full keyword access. And so for the second example, we have our accessibility label. It's complicated inside an Elangenzone split second chronograph, where we set our user input labels to article and also news, as this is a good alternate for article as well as the accessibility label itself. As in the above example, tap to copy link really doesn't make sense to have as dictated input. The label of the article is still an option, and as mentioned before, with partial matching, it's still a valid way to activate that element. And so this looks, again, a little different in SwiftUI, but it's relatively similar. We set our accessibility label, we set our accessibility input labels, and note, and I've been burned by this, whereas in UIKit, we have an accessibility user input labels. In SwiftUI, it's called accessibility input label. So if your autocomplete is not working because you're trying to snug in user, that's why. And then for a second example, we have our accessibility label again and our accessibility input labels, where now we're recopying the whole label, although, you know, in the end, we'll probably still have some kind of model where we can pass this in from. But in terms of the API, it's relatively similar. So let's now take a look at a demo of voice control. Hey Siri, turn on voice control. Show names. Tap send transfer. Tap 1. Tap share link. Tap copy link. And so for our third and final act today, we're going to take a look at the long-awaited full keyboard access, which is, as said before, the newest addition to the family of these assistive technologies. And after all of this build-up, it must be super impressive, right? Well, yes and no, but probably in a good way. So let's go back and take a look at this comment where we say, use this property when the accessibility label isn't appropriate for dictated or typed input. And whilst we had dictated with voice control, with full keyboard access, we have typed input. So this property is going to work magically to enhance your app to allow for full keyboard access as well. And so really all we have to do is, well, not that much really. And isn't that great? Sure, we've put in a lot of work, but we've made our app accessible with VoiceOver. We've made our app then accessible with voice control. And now we have our app accessible with full keyboard access pretty much without putting in any work. And obviously this is not exactly true in real life, as navigating with a keyboard, as we will see, still requires certain containers to be set, and like you definitely are going to want to like double check and navigate through your app with your keyboard. But I've been so impressed, like going and setting up an app for voice control and VoiceOver and then using full keyboard access. it's just a joy because it just works. And so let me show you what that looks like.
So once again, we're here in the WeTransfer app, and now we're going to navigate through it using full keyboard access, and we're going to try and upload a file. So we can use tab, and we can use tab to go through certain containers, and we can also find what we want to navigate to. And we can use the accessibility escape and do a tab B to go back. But now what we want to do is to upload a file. So let's find the upload file. And then we are going to take something from the photo and video library. Great, we have an image from our offsite. Fantastic, let's go to next. And let's get as link. And then let's transfer the file. There we go. Our link is ready, and we can share, we can copy the link, or we can exit out.
All right, so we've gone through setting up your app for VoiceOver, for voice control, for full keyboard access. These words are going to be rattling in your brain for the rest of the day, I bet. Let's look back and see what we've discussed and what we've learned. So adding VoiceOver support to your app gets you most of the way there, as in it's a great base to extend and support assistive technologies like voice control and full keyword access. And then adding voice control support will get you pretty much all the way to also support full keyboard access on iOS. Oh, and before we end this presentation, there's one last thing, and I'm super proud of this. WeTransfer has a what we call mission accessible, and as a company, we are working very hard on really improving the accessibility across the board of all our products. And it's a big pleasure to be able to work on this kind of project and to make WeTransfer's mobile apps specifically and all the other apps as well accessible for all of our users. Thank you very much. And here's some references that I've used in the presentation, including a great WWDC talk from no one other than Sommer.
Okay, so we just need to unmute. Oh, we're good? Okay, cool. All right, Baz, are you there?
I sure am. Hey.
Hey, awesome. Thank you for your talk. Does anyone have any questions? You get pins.
Got a question around, hope you can hear me from the side. Got a question around the use of Swift UI and accessibility labels. A lot of the time people are putting in a view into multiple targets, being Mac OS and iOS, iPadOS and all that. What considerations for using accessibility and making sure accessibility is appropriate for VoiceOver should be taken into account with the different targets?
That's a really interesting question. I think generally, and this was actually a question that was brought up in the chat as well, I would recommend in especially labels to use agnostic naming, right? So don't say like double tap to activate or whatever, because that will depend on if you're using a keyboard or if you're on Mac or if you're on iOS. And then I think in terms of labels, other than that, you should be okay. but definitely also test with macOS, test with all your, the platforms you support. And macOS is specifically interesting, and iOS is actually also going in that direction, where on iOS, we have a flat hierarchy for VoiceOver, right? So generally we go from top left to bottom right, depending on if you have your language in right to left or left to right, which is great. But in macOS, you have a very hierarchical system where, imagine a collection view and you go into a collection view, right? So you want to make sure that you have a name for your collection view and say, hey, this is a list of transfers. And then you go into that. So I don't think in terms of naming of labels, you're going to have to do very much other than, trying to stay agnostic. But you definitely want to test on the different platforms and figure out like, okay, what are things that are awkward on one platform versus the other. And then, it doesn't really matter if you're using SwiftUI or UIKit, you're going to have to do a little bit of extra work and figure out how to do that. But yeah, you can get there.
Any other questions? Cool, awesome. Yeah, all good. All right, so thank you, Baz. We're actually going to have a short break so you can stretch your legs. I actually do have enough pins for everyone, so everyone's going to get a pin. Feel free to ask more questions, please. Yeah, so a short break. There will be another hour of talks. So if you have to leave, you can leave. There's no pressure to stay. So yeah, so stretch your legs.
Great job, and thank you to Baz.
Thank you.
Yeah, he does. Yeah, we chatted with it 2 weeks ago.
Yeah, really good. All right, so Rob, you are there.
Yeah.
Bring it home.
So if you could start sharing your screen, please. There we go.
5 a.m.
When you're ready, Rob.
Excellent. Excellent. All good. Good to go. Hello, everyone. Thank you very much to Aaron and everyone else who sorted out this edition of Sydney CocoaHeads. It's a real pleasure to be asked and to share the session with some very knowledgeable accessibility people. Yeah, it's a great opportunity. Happy Global Accessibility Awareness Day, everyone, as well. As Bas says, it is an important day for the accessibility community. For some reason, my clicker likes making dunk sounds. So yeah, my name is Rob. I am a mobile accessibility advocate. I'm also an iOS engineer. Just a little bit about me to start with. I have a blog at mobileally.com. That's ally spelled A11Y. There's a bunch of information on there about making apps for both iOS and Android, although to be honest, mostly iOS, making them more accessible. So hopefully you'll find some resources on there that will be useful for you in future. As Aaron mentioned as well, I do have a book developing inclusive mobile apps, and that covers making apps inclusive and accessible for iOS and Android, covers a bunch of the APIs from Apple and from Google, but it also covers making an app from product perspective and design and testing and all that kind of stuff as well. Yeah, I do have a copy of this book to give away today. I will let Aaron decide who gets to have the book, maybe like best question or something. So start thinking up some good questions, but like save them for summer. Don't ask the difficult ones for me. Mobile accessibility is something that I'm really interested in. I always like to know people's experiences, whether that is as a developer or whether as a user or whatever your experience is with accessibility. So feel free to get in touch with me, ally, again spelled A11Y at mobileally.com. You can drop me any questions there as well. I'd love to hear from you. So today I'm going to talk to you about next level iOS accessibility. So we'll start at the very beginning. We'll start with level 1. So much of this, Bas gave you a fantastic account of earlier today anyway. So you'll be pretty familiar with it, I hope. But these are really kind of the building blocks of accessibility on iOS. So the accessibility label, the accessibility value, and the accessibility hint. So the label is kind of the name of the thing. The value is the value. So the value of text in a text field, or the value of the current value of a slider. And then the hint, which allows you to give some extra context if you need it. I just think carefully about where you're going to use that, as kind of Bas said earlier. And then the next two are accessibility traits. There's quite a lot of traits. You don't necessarily need to know every single one and what each one does, because they all do very different things. But accessibility traits are really fundamental to how accessibility works on iOS. They control what the utterances that VoiceOver speaks, but they also control how switch control or VoiceOver or whatever assistive technology interacts with that element as well, and how that element behaves. Some will add extra behaviors and features into your app just by using the correct trait. And how to show and hide elements from the accessibility tree as well. So being able to know how and when to add something to the accessibility tree or remove it from the accessibility tree are super fundamental and important technique. So those are the 5 things that I really consider kind of the basic building blocks of iOS accessibility. Hopefully, if you're an iOS engineer, you feel reasonably comfortable with these. If not, that's perfectly fine, but I would really recommend go and do a bit of research on all of these, because these are kind of, as I say, the absolute fundamental building blocks. If you get these right, you can make an accessible app pretty simply. But if you don't know how to use these, you're not really going to get very far with that. Check out mobileally.com. There are pieces on most of these, and I will try my best to add some over the next couple of weeks, because, as I say, I kind of really feel like this is something that everybody should know. So I will kind of add something there in future. So the next level is really about giving your app's best experience. So for a visual user, we might do this using design or using animation. But obviously, with assistive technology, that's not always an option. And depending on our users, they might not experience those at all, or maybe they might choose to disable them if they kind of cause problems or get in the way or something like that. So there's other ways that we can use to make our app's best experience for our users. And with the building blocks, we can make an app that is accessible and functional, but none of us wants to make functional apps, right? We want to make apps that are exciting and fun to use. And that's what next level accessibility is about. So there are 4 things that I'm going to cover in this session that are for the next level accessibility. There's a whole bunch of other things that you can do as well, and I'll kind of touch on those at the end, but I'm not going to go into detail of those today. But the 4 things that I'm going to touch on today, one of them is a technique, semantic views, and then we're going to cover 3 APIs from Apple: custom rotors, custom actions, and custom content. So first of all, semantic views. So what is a semantic view? A semantic view is a collection of views that are grouped together as one accessibility element. It's a view that has a semantic or a meaning when everything is presented together as one element rather than as individual items. It makes navigation faster and more efficient, as well as providing more context. And it works with both VoiceOver and switch control. And I'm just going to give you an example, but I did realize I forgot to share my audio. So I'm going to stop sharing for a second. And oh no. Excellent. I hope you enjoyed just watching my face as I changed settings on my Mac there. So hopefully you can hear the audio now. So this is an example of an app that I built. It's a super basic app, and it allows us to search NASA's image catalog. And in this example, we search for planet Mars, and it's showing images of the planet Mars, and we get the planet Mars because we've made the app accessible using the building blocks. Each image has an accessibility label, which is the title of the image. We've then got 3 buttons: a like button, a share button, and a save button, so we can save the image. And then we've got the title of the image. We can also tap on the image to go to a detail screen and get a little bit more if we want to, but we're not going to cover that in this session. So if we navigate this with VoiceOver, again, we've made the app accessible using the building blocks, but this is the experience that we get.
Composite image of the planet Mars taken by Hubble Space Telescope. HST button. Image selected. Liked button. Share. Save. Composite image. Springtime. Like button. Share. Save. Springtime on Mars radar opens. Selected. Liked button. Mars radar opens a planet 3rd dimension button. Image.
Okay, I hope you can hear that. If you couldn't, I have got the caption panel on, so hopefully at the bottom of the screen, you'll be able to see what VoiceOver is reading out. But essentially, to navigate that screen, we had to go through every element every time, right? So we wanted to go to kind of the 3rd image. We had to navigate each image. We got the title duplicated because our image has the accessibility label of the image title, and then we've got visually the image title underneath it as well. So we heard that twice for each image, and we also had each button for each image. Well, using a semantic view, we can group those elements together, and then we can use some extra techniques that we'll cover a little bit later to make that navigation much simpler. So I'm going to group those together now, and this is the example that we get.
Composite image of the planet Mars taken by Hubble Space Telescope. Springtime on Mars. Hubble. Mars radar opens a planet 3rd dimension. Liked. Button. Image.
So with that example, that was using a semantic view where we've grouped our image, our label, and our buttons together as one element. So now when we navigate, we're only accessing the important stuff, right? We're accessing the image and we're getting read to as the title of the image, that's what we want, right? So how do we do that? Well, semantic views, we build up using the building blocks of iOS accessibility. We combine them, and how exactly you combine them is going to depend on the app and how you've built it. But in this example, we've added traits. We've set something as being an accessibility element where it previously wasn't. We're using an accessibility label, and we're setting an accessibility value as well. SwiftUI, and this is why accessibility for SwiftUI is really fantastic. It's just one modifier, and it will basically do everything for you. Accessibility element, children, and then you pass the argument of combine, and it will take pretty much everything from the views, from its child views that's related to accessibility, and combine them into your new semantic view. So sometimes you will need to add some extra modifiers on there just to tweak things, but most of the time SwiftUI just does it for you with that one modifier. Sorry. So this is how we do it in our example in UIKit. So the view is a UI collection view cell. And we need to make the UI collection view cell an accessibility element. So we set that to is accessibility element equals true. We then set the accessibility label, which is going to be our image title. We add in 2 traits, button and image. and we set the accessibility value, which in our case was liked. So previously we had the toggle button for liked, which was just called like, and then it was either selected or unselected. Well, that doesn't really make sense when we have it as a semantic view. So instead of using the selected trait, we're going to use either a value of liked, or if it's not liked, we'll keep the value empty. And the traits, we need to add a button because you can tap on this to view detail about the image. And we need to add image because of course it's an image. And those traits add in extra behaviors for us as well, which we'll get to in a little bit. Now, we're going to cover 3 APIs in iOS, but before we do that, I just want to cover rotors. So rotors are a feature of VoiceOver in iOS. And if you're not a VoiceOver user, you might not be that familiar with them, but they're a super powerful feature of VoiceOver. So this is an example of how you activate a rotor. So you do it with a gesture on the screen. And it's called a rotor really because you kind of, the gesture you make on a screen is as if you're turning a rotor dial on the screen of your phone. So you can see there I was making that rotor gesture by rotating one finger around another, and on the screen the rotor appeared. This is with VoiceOver enabled, and I could iterate through various different settings. And that's the setting that I left it on was headings. Now different rotor settings will work in different ways, but in general, they will allow you to do certain things, and to control them, you swipe vertically. So instead of horizontally, as you generally would for navigating with VoiceOver, you swipe up to go to the previous and down to go to the next item. So in this case, I left it on headings, and I'm going to show you what that does. So here, we navigated just to the headings within this screen. And this is why I say that traits are really important. This is actually done for you automatically because we're using, well, this is the Apple settings app, but they'll be using a UI table view and UI table view headers. And UI table view headers automatically have the heading trait applied for you, and you can skip directly from headers, from header to header, skipping out content using that rotor. If you have any headers in your app that aren't a UI table view heading, you will need to apply the header trait manually to do that. But this is a super important feature for VoiceOver users because it allows you to skip to important content, to relevant content, meaning that you don't have to navigate every single item. It's kind of the equivalent of just quickly scrolling if you're a visual user. So let's create a custom rotor. Custom rotors make navigating to important areas with VoiceOver faster and more efficient. They allow skimming and skipping of content. So this is our example again of what it's like to navigate without a custom rotor. Here we're trying to navigate between locked images. So our first image here, you can see has the filled in heart, so that's liked. And I want to navigate to the next liked image. Now I know that the next liked image is actually the third image. So we can see 2 on the screen, there's the third one just below, and that is liked. But if you're navigating with VoiceOver, this is how we'd have to do it.
Composite image of the planet Mars taken by Hubble Space Telescope. HST button, image. Selected, liked, button. Share, save, but composite image. Springtime, like, button, share, but, save, but, springtime on, Mars radar opens, selected, liked, button. Mars radar opens a planet third dimension, button, image.
So again, we had to navigate through every image, every title, every 3 buttons for each image, until eventually we got to the like button and heard the selected trait. And once we heard the selected trait, we knew that that image was liked, and we could then navigate back to actually get to the image that we were interested in. So that's a lot of navigation. If we combine a custom rotor with our semantic views, we can make that way simpler. So here, in this example, I'm activating the custom rotor, and then I'm swiping down on the screen to access the next rotor item, in this case, the next liked item.
Composite image of the planet Mars taken by Hubble Space Telescope, HST, liked button, image. Use the rotor to access liked, moon. Headings, liked. Mars radar opens a planet third dimension, liked button, image.
So we completely skipped out that middle image. We skipped all of the buttons. We skipped the duplicate titles. So a much simpler way of navigating that. So how do we do that in UIKit? Each UIKit view has a property of accessibility custom rotors, and we pass to that an array of our custom rotors. We create custom rotors with UI accessibility custom rotor initializer, and we pass it the name, so in our case, liked. And then we get a closure with a predicate argument. We have to, in that closure, figure out what our next view is going to be, and we return a UI accessibility custom rotor item result with our target element, which is our UI view. So that's the next view that we want to focus on. And optionally, we've got a target range here. So if your view is a text view, and it's a specific piece of text that you want to focus on, then you can pass in a text range and it will hit that phrase. How do we pick the next view? So your predicate argument comes with a search direction property, so you can tell whether it's a next, you're going next or you're going previous, so whether someone swiped down or swiped up. And the view you need to return, well, the item you need to return is a UI view. The thing that is kind of complicated here is that you have to figure out from your data source whether it should be matching this predicate or not. So if you're using a view like a UI table view or a UI collection view, you can ask the UI collection view for the view at index. So you can search your data source, you find out the index in your data source and get the index from the collection view or the table view, and you can return that. But just bear in mind that if you do that, then there's a good chance that your view might not have been loaded yet, because they're lazy views. They're only going to load the views as needed. So if you say ask for the view at a certain index and that's not been loaded, you're just going to get nil returned back, which means that your users will get the experience of being told there's no further items when actually there is. So you're going to need to be a bit smarter here about potentially loading extra things, potentially calculating a scroll offset and scrolling to that before returning your view. So you do need to think a little bit about how exactly you're going to do that if you're using a lazy view. If there are no further items that match the predicate, then you should return nil. Don't return the rotor result item with a nil view, return nil. And that allows VoiceOver to make a slightly different sound. It will make a different sound depending on whether you have returned a view or not, so that your VoiceOver users know whether something has happened. SwiftUI is a little simpler. We want to create a custom namespace for our rotor. And the custom namespace allows us to act on multiple views at once. Wrap your view in a scroll reader. So presumably you have a UI scroll, a scroll view that your views are in. If you have that, you want to wrap that in a scroll view and a scroll reader, and that allows you to scroll to the next element, which is particularly useful again if you're using a lazy VStack. And on the views that you want to be potential rotor elements, you add the modifier accessibility rotor entry with the ID. So this is going to be the ID of your view, or most likely the ID of the item from the data source, and pass your custom rotor namespace. Then on the parent view, so this is most likely going to be your VStack or whatever stack that you're using to host your views, you add the accessibility rotor modifier. And again, you give it a name, in our case, liked. And we then want to find each item from our data source that matches the predicate. Now, this is way simpler in SwiftUI than in UIKit, because with SwiftUI being declarative, we don't need to pass the exact view. All we need to do is to return the ID of the view that we want to focus on. So in this case, we want to iterate through our data source. find every item in the data source that is liked, and tell SwiftUI that that should be a rotor item. And in this case, because I'm using a lazy VStack, I'm using the scroll view reader to scroll to that item as well. And that means that if the view for that item hasn't currently been loaded, it will scroll to that item before focusing on it. Just some tips with custom rotors. Make sure you localize the rotor name. Remember, if you're using a lazy view, like a collection view or a table view or a lazy VStack, that you can only iterate through the views that are loaded unless you kind of do something a bit smarter to load views before navigating to them. And if you're finding an element within text, you can pass an optional UI text range to reach the specific phrase that you want to focus on. Custom actions. I think my clicker has stopped working. Okay. So with custom actions, you can hide less common actions from screen navigation, making voiceover and switch control navigation more efficient. And this is essential for screens where you have lots of items or repeated items. So this, although it is kind of a slightly more advanced technique for UI, for accessibility in iOS, I really consider this like an absolute essential feature if you have a lot of repeated items. For example, if you have an e-commerce app and you search in the e-commerce app and it will tell you the item name, and then you've got two buttons for buy now and add to basket. Well, in that case, you're going to get item name, buy now, add to basket, item name, buy now, add to basket for every item in that result. And that's going to give you a lot of extra navigation, which is just not relevant. So we can hide those behind a custom action. So let's take a look at this example.
Composite image of the planet Mars selected, liked, share, button, save, button, composite image of the planet Mars taken, springtime on Mars, like, button, share, button, save, button, springtime on Mars.
So you can see there, we're navigating through every single button. You get the idea now, we've kind of done that twice already, right? It's really laborious. It takes a lot of effort. Your users are just going to get bored and frustrated. So instead, again, combining semantic views with custom actions, we can have this.
Composite image of the planet Mars taken by Hubble characters. Actions, activate. Like. Share. Save. Explore image. Activate. Default. Like.
So with that example, I'm using the rotor to navigate to actions. And then I'm swiping down to get to each action that is available on that item. Now, there was two actions that were provided to us by iOS. One of them was activate, and that is always the default. And we get that because we've added the button trait. So remember earlier when we made the semantic view, we added the button trait. And that means that accessibility on iOS knows that this is a button and can be activated. So it always adds that activate action in for you as the default action. And the last one was to inspect the image. And we get that for free as well because we added the image trait. Because we told iOS this was an image, it adds that for us automatically. So even if we hadn't added any actions, we would get those two for free because we've added the correct traits. The inspect image brings up a large image viewer, and it provides a machine learning generated description of the image. So this is fantastic if the developer of the app hasn't provided a particularly good description of the image, then VoiceOver users can then use VoiceOver to get a machine learning generated one as well. And it will also detect any text that's in the image and read that to your users as well through VoiceOver. But the three actions that we added were like, share and save, which means that we can navigate through each of these items, just get the name of the image, just navigate by image, and we don't have to care about the items, about the actions until we're actually interested in it, until we find the image that we want. I like this image, I'm going to save it, navigate to it, use the rotor to go to actions, and then swipe to save, tap on that, double tap on that to activate it, and the image is saved without us having to navigate each action every time. This is how it works with switch control. So custom actions also work really nicely with switch control. And with this particular setup of switch control, I've got auto navigation on, and it will iterate through each item. And we can, as we tap on that, you can see we've got the like, share and save, we've got the name, and we've got an image there as well to represent the action. So custom actions, each UI kit view also has a property called accessibility custom actions. And to that, we pass an array of UI accessibility custom action, which we create with a name. So in our case, it was like, share and save. There's a few different initializers for this. The one that I would generally pick would be using a selector, but there are other options as well. And for Swift UI, we use the accessibility action modifier. Again, we pass a name, and then we've got a closure to execute our code, which we would probably just want to call a function, I would think, from there, but you can add in whatever code you like. Again, remember to localize all of your action names. And for improved switch control experience, pass an image into the initializer as well, or into the Swift UI modifier that represents the action. If you don't pass an image, then switch control users as the image icon for that action, they will just get the first initial of your text label. But if you can pass an image, then that's going to give it a nicer experience. The final API I want to talk about is custom content. Custom content is ideal for hiding less important information from VoiceOver navigation. So similar to how we hid less important actions, we can also hide less important information. But that's actually not what I'm doing in this example. The reason why I really love this particular API is because we can actually use it to make a far richer experience for VoiceOver users than for people using your app without VoiceOver. And you can see this in the Photos app. So if you take a look at the Photos app where you've got all the thumbnails, if you're navigating thumbnails visually, all you get really is just the thumbnail of the image. But if you try navigating that with VoiceOver enabled, you can actually use custom content to get way more data about each image that you just can't see visually. So this is a fantastic API from 2 points of view. Either you can simplify your API or your interface, sorry, or you can add in extra content. So here's an
composite
example.
image of the planet Mars taken by Hubble. More content. The 29th of March, 1991, at 0. Date. Composite image of the planet Mars taken by Hubble Space Telescope, HST, Wide Field and Planetary Camera WFPC. Description.
So here, again, I used the rotor to navigate to more content. You might have noticed that as we kind of go through these videos, the number of options we get on the rotor is increasing. So some of these, like custom content, doesn't appear on the rotor until you add custom content. And then once I'd activated the custom content rotor, I swiped down to access each item of custom content. So the first one was the date. So it read the date followed by date. And then it read the description of the image, which was actually the description of this image is not a great example because it's basically the same as the title, but they are different in the NASA API. If we'd have gone one further, it would have told us the NASA organization was responsible for the image as well. So to create these in UIKit, this isn't actually built into every UIKit view as with the others. With this one, you have to implement the AX custom content provider protocol on your UI view. So either conform to that or extend your view to conform to that. And then that includes a property of accessibility custom content. And to this, again, you pass an array of your AX custom content this time. So you initialize this with AX custom content with your label and your value. So it's really just a key value pair. The value is read first by VoiceOver, followed by the label. So in our case, it read the date followed by the word date. For Swift UI, we have the accessibility custom content modifier. Again, we pass the label and the value to that. And you can add as many of those as you like to your view. And remember, as with the other things that we've mentioned, you should localize both the label and the content. So those are the things that we were going to cover in our next level accessibility, but there's a few kind of bonus things that I just want to touch on that I'm not going to cover today, but I think are really worth mentioning. The large content viewer, attributed accessibility labels are incredibly powerful. You can do some really special stuff with those. Accessibility notifications, accessibility escape, magic tap, and user input labels, as Bas covered the user input labels earlier. These are some fantastic APIs provided by Apple to take your accessibility to the next level. So these are the 4 things that we covered. Semantic views, which is the technique of adding the building blocks of UI kit accessibility together onto views to give them a meaning when grouped. Custom rotors, which allows us to navigate to content faster than navigating every single item. Custom actions, which allows us to hide less common actions behind a rotor. And custom content, which allows us to either hide content that's not necessarily immediately relevant or add additional content for voiceover users behind a rotor as well. And so that's it. The only thing that's left now is for you guys to go away and level up your apps. Thank you very much.
Does anyone have any questions for Rob? Anyone? Yeah.
I guess it's not directly an accessibility question, but in the suggestion of localization of values, for example, those externally sourced NASA images, I can't imagine NASA does great Japanese or Finnish content descriptions to localize. So any suggestions of how you might go down that path? As I say, it's not really accessibility, but if you're going to go localized.
Yeah, so well, first of all, there is kind of a bit of discussion, I guess, around whether localization is accessibility or not. I kind of roughly fall on that it is accessibility. The reason being, there's a good number of people who will not speak your local language or not use your local language. It's around about 20% of people, roughly internationally, or obviously it varies by country, don't speak the country they're in's main language. So if they're more comfortable using a different language, then using an app in another language is just going to make that app that bit harder for them to use, because they're going to have to do that extra mental processing. You've got that extra mental load. So yes, I would kind of argue roughly on the side that localization is kind of in the area of accessibility for that reason. But yeah, so in my example, I used the NASA API. Yes, NASA only really provides data in English. So it's not a fantastic example. I'm talking kind of here in general strokes of, in your own app, in your own apps, if you're going to localize stuff within your app, make sure you also remember to localize everything related to accessibility. So I have seen in the past where apps have been localized for visual labels, but then accessibility content has kind of been forgotten about. So it's important that if you are going to localize, that you include the accessibility content in with that as well.
Any other questions?
Yeah, you go first.
I've asked too many questions.
Yeah, well, my question is not directly related to the topic.
Okay then. Hey Rob, great talk as always. So I've seen a lot of apps that go one way and sort of completely customize the accessibility experience, and others that go more for the relying on the system behavior for accessibility. Do you have any tips on how you can sort of strike a good balance between when do you go down a customization route versus when do you rely on system behavior?
So as a general rule of thumb, as I kind of mentioned, if you have lots of repeated items, that's a sign that you should be doing something a bit more custom. That's in the example that I gave. That's kind of why I've got the each item with a duplicate title and I've got 3 buttons, because it means you're navigating a bunch of the same stuff all the time. When you've got something like that, then you definitely want to be doing something custom. Anything more than that, I would highly recommend user testing if that's a resource that's available to you. It depends on obviously the size of your organization, but user testing for accessibility is super important, because accessibility is about humans and about how people interact with your software. So unless you get real users who are actually using assistive technology as kind of their normal way of interacting with apps, you're not necessarily going to get the right answers on that. So I'd highly recommend user testing and getting some valuable feedback from there. In general, I have seen apps in the past where they've kind of made a completely different interface for assistive technology. I would not advise that. It tends to result in the kind of ghettoization of accessibility, that it tends to be forgotten about and it never quite matches up. Plus also remember, the whole point that I wanted to make an image app for this example is to make the point that people who use VoiceOver often will have some sight and will still want to see images. They maybe just have a slightly different way of interacting with the app. So if you make your VoiceOver experience completely separate, then that's just not going to match up for people who do have some vision. And for people who are using switch control, that's just going to make no sense at all. So the best advice I can give is, if you have repeated things, do something more custom. Anything more than that, get some user testing advice.
No question.
I just want to ask, Rob, what was the last cool thing you've seen through the telescope that is in your background?
I haven't actually had it out much for a little while. It is just coming into spring now here. So it's kind of, I don't know, it's been a little cold for me to stand outside for hours with a telescope. But when I had it out last summer, I did manage to see quite a few of the moons of Jupiter, which is very cool. I've not seen those before. To be honest, I'm not 100% sure I know how to use it properly. So I'm looking forward to getting it out again a bit more this summer.
Well, having access to NASA pictures probably, it's more pictures there.
Yes, yeah. NASA is definitely better at taking photos of the sky than I am. Actually, I did think of my favorite thing through the telescope was actually the moon. The moon just looks wild through a telescope. If you haven't seen the moon through a telescope, I highly recommend.
Any other questions? Okay, thank you, Rob.
Thank you.
Okay, so is Summer there? It's 6:20 a.m. New York. Oh, wow. Are we online? And there we are. Good early.
I'm awake. No promises beyond that.
Awesome. So you can take it away, Summer, whenever you're ready. You start sharing your screen.
Okay, let me get that going and we'll get started. This all worked yesterday when I did my pack check, so we're just gonna hope for the best.
We've had technical problems with every presentation, so.
All right, can we see a slide? Okay, looks like we can. Awesome. Okay, well, hello everyone. It is indeed 6 a.m. here, so I'm going to give it my all, and hopefully this goes well. So my name is Sommer Panage, and I am super excited to be here bright and early to talk to you about, obviously about accessibility, because it is Global Accessibility Awareness Day. And specifically, what I want to go into today is cognitive accessibility. So just to start off, I will share a bit of info about me and my background in the space. So I've been working in the accessibility space for about 12 years now, and my clicker not working? That's not good. Wait for it. Okay, we'll use the mouse. So I've been working in the field for about 12 years, and I'm currently managing a cross-platform team of awesome accessibility engineers at Slack. Before that, I managed one of the 3 groups of iOS accessibility engineers over at Apple, and we did awesome, really fun things like backtap, we did sound recognition, and a whole bunch of voiceover support, of course. And I also did mobile accessibility over at Twitter for about 3 years as well. And if you follow me on Twitter, you will know that none of that matters as much as my cat Smalltalk, who is my actual boss. So what are we going to talk about today? Well, we'll start with the basics. What is cognitive accessibility? And not just thinking dictionary definition, but really, how do we think about cognitive accessibility? How do we think about how people think? After that, I'll move into 4 key areas of consideration, talking about both high-level concepts that apply across all platforms, as well as pulling specific examples from iOS, which is where my experience is the strongest, so I can definitely illustrate things the best there. And finally, I'll dive into some cross-cutting themes and takeaways from all the previous sections to close out the talk. And of course, always invite questions at the end. So what is cognitive accessibility? We often talk about accessibility in terms of abilities. So when we think about different abilities folks can have, there's of course vision, which would lead to discussions around things like someone preferring larger text, or maybe someone who is blind using a screen reader like VoiceOver. We might talk about accessibility in terms of hearing, or the ability to hear, which leads to conversations around things like captions, or including images and sound, or text and sound to convey information. We might also think about accessibility in terms of the motor space or motor abilities. This might be where conversations around tap target size happen in our iOS apps, or when we're talking about switch control or keyboard navigation for users with limited motor abilities. And so that brings us to the 4th area of ability, cognition or cognitive accessibility. Here we're talking about considerations we make for those with cognitive or learning disabilities. How can we change how we develop to better support people who think in different ways? Then a common question I get asked at this point is often, what kind of cognition or what kind of learning disabilities are we talking about? And in some ways, that's a hard question to answer, not because of the size of the list or it's obscure or anything, but because it doesn't really give us a lot of information. So for example, here are some of the conditions we might be thinking about. There's Down syndrome, Fragile X syndrome, dyslexia, ADHD, depression, autism spectrum disorder. And we're also considering those who have aging-related conditions, or even those who are just still learning. And that can mean many things. That could mean being new to tech, learning tech. That could mean learning a language. That could mean learning to be a person, i.e. being a small child. So there are many different things and abilities here. But as you can see, the list itself didn't really tell us a lot just by naming disorders or deficits. It's like knowing that someone has a detached retina, but not knowing that that leads to vision impairment. So what we really want to know is, what is the experience for these folks? That's what we want to think about. So when we're talking about the difficulties that might present themselves as developers, we also want to think about how we can solve for them. So what are some of these deficits or difficulties that might come up? Well, there might be difficulties understanding content. So this could mean reading or listening comprehension, or perhaps it might mean trouble understanding symbol or icons or recognizing faces. Some folks might struggle with completing tasks due to being easily overwhelmed or distracted. And this could also be a result of the previous deficit. In other words, it can be hard to complete a task if you don't understand what to do. Some folks might struggle with memory, and this could be short-term memory or long-term memory, and they could impact us as developers different ways. Some people might have difficulties communicating, and this could be via text-based input or communicating verbally. There's lots of different ways that could manifest as well. Time management can also be a struggle for some due to, for example, being easily distracted or pulled away from a task. And others might find numbers or dates or times or mathematical concepts difficult. So when we start to think about cognitive accessibility in terms of abilities, instead of the names of conditions or disorders, it becomes a bit clearer how the way we build our apps, our products, and our content can impact how easy or how difficult it is for someone to use them. And it can also become much clearer now that cognitive accessibility is really about everyone. So what do we know about this topic? Now that we know a little bit more about what we're trying to solve for, what does the literature and all the guidelines tell us? So a lot of the guides today we have has been summarized by the WCAG, which is a terrible acronym in my opinion, but stands for the Web Content Accessibility Guidelines. And they specify that all content in our applications must be POUR, P-O-U-R, meaning perceivable, operable, understandable, and robust. And this rather long document covers all forms of accessibility, so vision, hearing, etc. And some sections particularly apply to the cognitive space and make recommendations in that space. Now, you might be thinking web, but this is about mobile, it's about iOS. And the great thing is a lot of these guidelines are cross-cutting, but something I really want to do today is focus in on that mobile aspect or on that iOS aspect of the guidance that we do have. And before I go further, I do want to note something. To date, there's still quite a limited amount of research in the cognitive accessibility space, particularly as it applies to technology and mobile technology. So in this talk, I'm going to use the WCAG, or Web Content Accessibility Guidelines, as a structure, and I'm going to pull from them. But I'll also be using my own experience in industry, working with and talking to users and caregivers, and I'll also cite some preliminary studies and case studies that exist in the literature. My hope is that as time goes on, we'll continue to see more and more understanding and research in this space. So I plan to update this talk a whole lot over the years. So with that, let's get into the main content. Well, you can divide the topics of cognitive accessibility in many ways. I tried to summarize the key guidance in 4 main areas, and I tried to make sure that we can see all the major themes that will cut across these areas. So I hope you'll kind of catch on to them as I go. So the first area that I want to talk about, and that is extremely important, is the content of your application itself. So as a user, can I consume your content? And this can mean 2 things. Is the content perceivable? And once perceived, is it understandable? In other words, perceivable and understandable content can be consumed in some way by all users. So let's dig in some more. How do I make sure that someone can perceive my content? Well, first of all, that means they can visually see it. And you might be thinking, wait, that's visual accessibility. And it is, but it's also cognitive accessibility. So it's important that you support larger text sizes in your apps for cognitive accessibility as well. Some studies indicate that just by increasing font size, people actually increase their comprehension and speed of consuming text. Larger text and larger UI also means that there is less on screen and there's more space. If done well, I should say. And less on screen can mean less overwhelm and less distraction. And all of this means that a user is more likely to be able to perceive and understand your content. In other words, improving perception can sometimes decrease cognitive load, and that in and of itself can lead to improved understanding. So let's take a look at this in practice. Here, this is a little demo app that I made that I call All About Cats, or ABC. And this is the UI. Obviously, I'm not a designer, so it's functional, and that's what we're going for here. We have a list of our favorite cats, and it's looking okay. So what I'm going to do now is I'm just going to scale up the text size or dynamic type on my phone. And you'll notice a few things right away. Firstly, the important information is just easier to see, which means that the user will have to spend less cognitive load or cognitive bandwidth trying to perceive the information in the first place. Secondly, there's just less on screen, there's more white space. And Instead of having to look through maybe 8 cats and all the associated information with all those cats, and then make the decision, how do I want to interact? Do I want to scroll? Do I want to tap into one? The user now only has to take in 1 to 2 cats before making decisions about how they want to interact. So for someone with cognitive accessibility needs, this spreading out of information visually can actually improve the experience. And perception extends beyond just text size. It also means supporting system color and contrast settings as well. Bold text, increased contrast modes on your device, these should all work correctly. But even without any additional settings on, the default contrast should always maintain a minimum of 4.5 to 1. And you can check that using Accessibility Inspector on your Mac, or there's tons of online contrast checkers that you can use as you build your application. Finally, not everyone can perceive content well through the modality that you have chosen. So for example, if your app has a lot of text, you'll want to make sure that it supports spoken content technologies like SpeakScreen on iOS. And the great news is SpeakScreen will generally work great if you've already done the work to support VoiceOver. If your app relies heavily on audio, then you'll want to be sure you're providing captions. Captions are not just about users who may be hard of hearing, but they also benefit cognitive accessibility as well. We have some research that shows that hearing text while reading it increases comprehension overall. Now let's talk more about comprehension and understanding. Once a user can perceive your content and take it in, there's still the question of, do they understand it? Well, you can't control user-generated content. In other words, Twitter can't control what users tweet. You can manage how you yourself as the developer or the writer use language. And this is particularly important when you're directing the user to do something, providing instructions, maybe for a game, for example. So a few key things that you can think in this space are avoiding idioms and jargon, avoiding abbreviations and making sure to define them, or making sure to define them on first use, and then also providing an easy way to look them up if needed, and striving for about a middle school reading level or lower. And there's many formulas for calculating reading level, and you can find some of those online where you can quite literally just paste text and it will give you an estimate. I haven't seen guidance on specific numbers to aim for, but generally just trying to keep it as low as you can. Keeping your language simple is a really good rule to go with. So here are 2 examples of the welcome page for All About Cats. The first one says, with ABC, you will come to know every little nook and cranny of the feline realm. Stay in the know of what your fluffy friends are up to with our favorites list, and even initiate your own fur baby into our meow space. It's interesting, but is this something everyone could understand? There's an abbreviation that's not clearly linked to All About Cats in the title above. There's a bit of idiom there with nook and cranny, and we never actually say the word cat in this main description. We also don't define what meow space is. So let's see if we can do better. Over on the right panel, I give it another try. I say, you will learn all about the cat world with All About Cats, ABC. Keep a list of your favorite cats and even add your own pets to our kitty social network called Meow Space. Now notice how I define the acronym, I simplify the sentence structure, the vocabulary is a bit simpler as well, and I reduce the reliance on metaphor. This language will welcome many more users who are excited about cats to my app, and that's good news. So now let's go back to an earlier part of the talk, where I talked a bit about the different deficits or difficulties that we're trying to help solve for. Who are we helping when we think about these things? Well, when we improve how users can perceive and understand our content, we're helping those who, of course, might struggle with comprehension. And by simplifying our language itself, and especially providing definitions for acronyms, keywords, or phrases, we're also helping those who might not remember certain phrases or what certain acronyms mean, essentially those who may have memory difficulties. Okay, moving on to the second area I'd like to highlight, and this is the notion of time. As a user of your app, do I have enough time to complete tasks that I'm trying to do? Looking back into our POUR acronym for perceivable, operable, understandable, and robust, this fits into the category of, operable. In other words, if I've timed out of some action, I'm certainly not operating things the way that I want to. Put another way, your users should always have enough time to consume your content and complete tasks. And this is something that has probably impacted all of us at some point. It tends to be most commonly an issue in areas like banking and financial software or government software. So for example, if you've ever been applying for a loan or working through maybe visa paperwork and you've gotten timed out, and worst case scenario, you've lost all your progress, this is the type of issue I'm talking about. And of course, that was a worst case example, but beyond that larger issue, there's also simply the risk of running out of time due to being distracted, for example. So what can we do? Well, when it comes to time limits, the best time limit is no time limit. In other words, if there's no strong security or privacy case for a time limit, there probably doesn't need to be one. If, however, you are indeed working on banking software, for example, then there might be such a case for you. And in that case, there are 3 different ways we can improve the user experience. You can simply allow users to disable the time limit in your app's settings, but this might not be permissible. In that case, you might be able to allow them to adjust the time limit in your app's settings. And a third option that you'll see, I think, most commonly with, if you have like a banking app or something on your phone, is allowing for extension of the time limit in real time. By giving the user ample warning that a session is about to time out, and the ability to extend their session, you're preventing, with a small interruption, you're preventing a far more severe disorientation of being completely logged out or losing their place in a process. So here's a very simple example of what that UI can look like. This is a kind of banking app, and we can see that a time expiring alert has come up. It gives the user the option to extend. It lets them know they have 1 minute left, or they can log out manually now. Now, if you're not working in banking or financial software, for example, this is probably one of the easiest of the considerations to follow along with. Should I have a timeout? No. But if you are in a situation where there may need to be such a thing, this is a really great place to engage your designers and your product folks in a discussion about how to best mitigate these issues for your customers. And there are a few more ways we can look at time. Moving past this more obvious case of an entire session timeout, it's also important to think about how a user can get pulled away from a task. Distraction can prevent a user from being able to finish a task in a timely manner. So while we can't control outside distractions and we can't control notifications from other software, we can control our own in-app experience. So here we see our user is trying to edit their kitty's details in All About Cats, and all of a sudden a terribly designed in-app notification arrives. Now, some of us might not be bothered by this, but for others, this could be very distracting. A user might tap the notification and transition to another part of the app, forgetting or losing track of what they're doing. They might worry that they've done something wrong to cause the interruption. So it's important for users to be able to disable any types of in-app notifications, sounds, and alerts, etc., that happen in your application. These things don't respect system device level notification settings. And so this will be something you'll actually need to do additional settings for if your app does rely on these types of in-app behaviors. So finally, when it comes to interruption, if for some reason a user does get logged out or pulled away from a task in some way, it's important that, if possible, they're guided right back to where they left off after relogging in, for example, and the data is never lost. This will give them the best chance of finishing whatever they were doing. Now, going back to that question we asked in the last section, who is this for? Who are we helping? So thinking of our list of common cognitive deficits, work that we do in regards to time will greatly help those who might struggle with task completion or, more generally, time management. But as always, it's not absolute. For example, this work around time will also help those who might take longer to understand content. Okay, moving into our third topic. I want to talk about how we think about navigation in our apps. Our navigation structure at any point in time should be able to answer, where am I and what am I doing? In other words, a user should always be able to know where they are in your app, how to get back to an earlier state, and how to progress in their current task. So what does this mean for us as developers? Well, it means we should always have titles on our pages that indicate where the user is. Additionally, headings are another great way to help users orient to where they are currently. And of course, we want to add the correct annotations via accessibility traits or roles so that the screen reader can also know that these are headings. So let's take a look at All About Cats again. This is the page for cats in my network. You can see that some have local tags and some have friend tags, and the title says meow with a cat emoji. It's all cute and it makes okay sense, but I think we can organize it even better and more clearly, and we can certainly improve that title. Now, let's take a look at the exact same page, but just structured a little better with better use of titles and headings. The title now clearly says my cats, so at any moment, I have no doubt what page I'm on. And additionally, I've used headings to help structure the page to show that, in fact, there are two groups of cats that this page contains, friend cats and neighbor cats. So sometimes our users will need to not just look at content, but find content in your app as well. So it's ideal to provide multiple ways to do that. Sometimes we'll provide a search, but we won't offer other ways to search. So we want to provide searching, filtering, perhaps a table of contents, and sorting. So by adding all of these, depending on how someone finds content best, they'll be able to use that method to find the content they're looking for. So here in our Cats app, if I go to the All Cats page, there are just way too many entries to look through, but I can both search and filter, which helps me narrow things down to the cats that I'm interested in. And as I continue to develop this app, I'd probably add sorting as well and allow users to sort by many different features of these cats, like age, name, and location. When it comes to going back in navigation, it's important to clearly indicate how to get back. While some users just know about a back gesture, you'll always want the clear visual affordance as well, letting a user know both how to get back and where back is. If you're working on larger screen devices or a web app, in addition to maybe an iOS app, then there's some initial evidence that we have that using breadcrumbs can help reduce the total number of taps or clicks that a user needs, as well as helping reduce errors in navigation. But for the iOS and mobile form factor, breadcrumbs can actually be more confusing because they will often wrap to multiple lines and it's not clear what leads to where. So we want to stick to a standard navigation stack whenever possible with mobile iOS apps. And showing the back arrow plus the title is going to be key so users know how to get back one step at a time. When it comes to going forward or making progress forward in a process, we want to be sure to provide all the info necessary to do this. So links should be underlined, and buttons, we have mounting evidence for them that the best way to communicate meaning is to combine both image and text whenever possible. Error recovery is important too for moving forward. So we want to help users both prevent errors and guide them to fix them when possible. And I'll talk a whole lot about that more in the next section. Lastly, we're also learning that users tend to be able to better understand UI progress and UI flows when they favor depth over breadth. So this means preferring moving deeper into the navigation stack to show more info rather than having fewer individual screens that are more content or task heavy. So let's look at that last concept of breadth and depth in our Cats app. Here is the sign up page. This is the first version of it, and it illustrates a breadth-based navigation. We have a lot of information and requests in this view. We want to know name and location, favorite food, detail, all kinds of details like that. And if the user gets one of these items wrong, of course, the whole page won't submit, and there's just a lot being asked for here. So this has the potential to be overwhelming. Now let's look at the same exact requests for information in a depth-based format. So rather than the sign-up info all being on one page, it's now being collected one field at a time per page. And this means that mistakes can be more easily identified and corrected, and progress flows much more linearly rather than the user perhaps being distracted and jumping around as they try to fill it out. Now, of course, I've shown two extreme ends of the spectrum here, but evidence overall is pointing us, I think, towards this depth-based style, helping us create more understandable experiences for some users causing them to make fewer mistakes. So I think that's good news, and I think it's something we can start to prefer in our app development. So coming back to this question one more time, who is this for? Who are we helping here? Well, again, this will help everyone when we pay attention to making fantastic navigational context, but particularly this will benefit those who might struggle with task completion or memory. Okay, we've made it to our fourth and final area, errors. Users of your app might sometimes wonder, did I do this right? All users make mistakes, and some groups are more likely to make them. And for those people, it can also be harder to recover from errors. So as developers of apps, it's up to us to make it as easy as possible to recover from errors and also to help users prevent them in the first place. In other words, users should be guided to both avoid and correct any mistakes they make. So let's talk about avoidance first. We want to confirm any destructive or high stakes actions. Delete your account, delete the song from your music library. Once an action like that is taken, there's almost always no way to undo it, at least not easily. So we want to give the user a chance to be really sure that this is what they mean. Another way that we can do this to help avoid errors is to signal an action really clearly. So we can use color and text and shape and symbol to help indicate the meaning of an action, particularly one that might be risky or destructive or high stakes. And finally, each platform is going to have its own norms where different UI goes. So on iOS, the back button is, depending on your language, going to generally be the top left. And that means that the top left is never where I want to place something that is a very high stakes action, especially if I have a navigation context already flowing. That would be a really bad place for a delete your account button, for example. So if you are working in a custom UI system and not using standard navigational structure, it's still important to keep in mind where things would go in a standard navigational structure to be sure that you're not creating high-risk scenarios for your users. So here we can see I've updated the edit profile page in my app to provide a delete account button. I put the save button up in the top right, which is a bit more of a canonical spot for a done or save button. And I've added a big delete account button at the bottom of the page, far from text fields and far from save. In addition, it has a trash icon. It's bright red. It uses bold text. So we've got color, symbol, words, all emphasizing that this button is not maybe the friendliest button. And when I tap it, I will confirm with the user that yes, they really do want to delete their account. So what about helping users correct mistakes that they've already made? It's key to have UI that allows users to easily undo things whenever possible. And sometimes this is really trivial, right? A play button becomes a pause button when pressed. We're just undoing our play. And sometimes we can provide ways to delete and undelete things, either directly or via a recently deleted cache. Generally, a great question to ask yourself is, if a user taps this button in my app, should there be, and is there a good way for them to untap it, so to speak? Additionally, when a user does make a mistake and something like form input, try to guide them. Saying wrong with a big red X or a generic message is definitely easier to code, but it's not going to help as much when it comes to trying to fix the issue. So try to be specific and helpful in your error messaging. For example, if the user fills out a zip code field with too few or too many digits, a message that explains maybe something like a zip code in the USA requires exactly 5 digits could be far more helpful than something went wrong. So here's a very simple example again in my edit profile page. There's a zip code field and we have an inline error message that lets the user know very close to where the error was committed, what's gone wrong. We've used some color, we've used some symbol as well to help guide them. And the text itself gives information. Please enter a USA zip code that is 5 digits. Finally, just a few more reminders when it comes to getting things right. Whenever possible, it's really important to use the device's standard UI keyboard on mobile to support dictation, etc. Essentially, we want to provide users with forms of input that are most natural for them and easiest for them to use, which is generally going to be the standard forms of input for our platform. Doing something like a custom keyboard can sometimes be fun or look really great, but it could also make things a lot more difficult for your users, especially if they also might rely on a screen reader or other technology. And again, coming back to our key question, who is this for? Who does this help? Well, this definitely might help those who struggle with memory. And this kind of work can also help those who have deficits around numbers, because if you're asking for name or for, addresses, dates, ages, things like that, those things can be particularly challenging for this group. All right, so with that, now that we've covered our 4 main consideration areas, I want to look at some overarching themes. So we just talked about the many ways that we can make our content more perceivable and understandable. We discussed how to watch out for common issues that disrupt users' use of time. We talked about the importance of clear navigation and how to help users prevent and recover from errors. If there's one thing I hope that you noticed during all of these topics, it's this overarching theme. A lot of the accessibility work you are already doing will support cognitive accessibility too. Flexible layouts, dynamic type, voiceover support, captions for AV content. Doing all of that by its very nature will also help many of the cognitive areas we discussed today. Voiceover support for blind and low vision users means that speak screen will likely work well for those who prefer spoken content. And we talked about captions for the hard of hearing, also helping those with helping folks with reading comprehension. So the work you're already doing and the work you already know about is really, really great for cognitive accessibility as well. Another major theme of almost every section we went through was to be predictable. Design patterns are patterns for a reason. By using standard navigation stacks, tab bars, breadcrumbs in our UI if necessary, we rely on predictable and sometimes even well-researched patterns that help users navigate our apps. It's also important to state what we might think as the developer is obvious. So titles, button names, clear indicators of time and space throughout the apps, headings, etc. It's all very important. And another big one, respecting system settings. Things like bold text, high contrast. If a user has a system setting enabled, they will expect or predict that it will function in your app too. So that's really important. A third theme was around redundancy, saying things in different ways. Icons and text, color and text to indicate meaning, pairing audio with written content. We want to give users different ways to understand our meaning, because how we best communicate in our app might not be how they best understand. And finally, adapt, adapt, adapt. Once again, this means respecting system settings. Yes, I'm going to keep saying it. And it also means that sometimes you might even be adding your own accessibility settings to help your app adapt to users' needs. For example, you'll notice that both Apple Books and Safari have their own additional font and size options beyond just standard dynamic type to give users even more ways to read because they are text-heavy apps. The Slack app offers numerous accessibility settings around what we talked about earlier, in-app notifications and sounds, with the hopes that this can help improve the experience for many different kinds of users. So with that, let's wrap up. Today, we learned about what cognitive accessibility is and focused on the key cognitive deficits that someone might be working with rather than the names of particular disorders. We thought about understanding, task completion, memory, communication, time management, and numbers and math. We then looked at key areas to consider in our own apps as we think about these deficits. Can users consume our content? Do they have enough time? Can they navigate it? And what happens if they make a mistake? Finally, we looked at overarching themes. Firstly, the accessibility work that you're already doing helps with cognitive accessibility, so keep doing it. Next, say things in different ways and combine different media. Be predictable, use standard patterns and respect system settings, and of course, adapt, adapt, adapt. Add your own settings if you need to. I hope this talk has been helpful, and I'm so grateful for the chance to speak with you today on Global Accessibility Awareness Day. I'm happy to take any questions now if we have time.
Thank you, Sommer. Yeah, we have time for
We can't find my Zoom screen. 1 second. Okay, well, I guess I just can't see the Zoom screen, but I'm here.
Okay, we can see you. So,
okay, great.
Does anyone have questions for Sommer?
There we go.
Yep.
Hey, Sommer, as always, love your talks. With the differences in people's cognitive abilities, I find it ties a lot to diversity as well. In your experience, how would you sort of come to learn and understand more about the different ways people think through problems, approach products, apps, stuff like that?
Yeah, I think that's a really good question. It's not always easy. I think that earlier Rob mentioned if you can to look into to get external user testing if that's something you can have the ability to do. And I think that some groups are starting to look in the neurodivergent community for user testers as well, and that can be a really great place to observe and understand how different people might use applications and might use mobile devices. So that's definitely one thing that that you can do. But sometimes it's as simple as just talking to people, even in your own life. Cognitive accessibility is a massive spectrum. And I think that I've learned a lot just from folks in my own life who openly identify with ADHD or with depression or with autism spectrum disorder. And if they're willing to share with you different challenges they have, there can be so much to learn even from those little interactions, just like things around how distracting in-app notifications can be. That was not something I had really thought about. And then after talking with just a couple people, coworkers who openly identified with issues in that space, I really was able to learn a lot about the challenges there. So I think external testing is a great resource. I think that people in our own lives, if they're willing to share their experiences, I think in the cognitive space, there is such diversity there. We can even learn a lot from them. And more so, I'm finding people openly sharing in online spaces, even on Twitter, for example, about their experiences with technology. And I've learned a lot from those places as well. And of course, someone's tweet is not research, but I'm still just hearing their voice and learning from their experience. So I think any place we can open our ears and just listen, we're going to learn a lot about being more inclusive in the cognitive realm.
Any other questions?
Yeah, look, just thinking about the situation where you're at right now, where you're at 6:30 in the morning, we're at 9:30 at night. We're starting to see sort of light settings and that change in technology. Do you think it'll actually expand further, like, for example, into cognitive areas? So, the app could change based on the time of the day and how it responds, based on possibly the potential of the person's cognitive processes at that time?
I think I missed the first part of I think I missed the first part of the question. So are you asking if apps can shift via kind of based on time zones?
Yeah, do you think it'll expand? Do you think that, as I said to you, that you're starting to see that technology changes its light settings based on the time of the day?
Yeah.
Could it go into the other spectrums, for example, the sounds and so voiceover and the cognitive aspects be changed throughout the day based on maybe moods and that sort of thing? Or do you think that sort of spectrum could be considered, or it starts getting overwhelming?
Yeah, I think so. It's one of those interesting things where there's always a fine line, right? We want the technology to be smart, to adapt to users and to meet their needs. But there's a fine line too, where when the technology starts doing things that maybe we don't expect or we don't understand, that can then be its own challenge for cognitive accessibility. So, but that being said, I do think there's plenty of space where technology can adapt to users in different ways, and potentially learn from them and adjust itself. or at least offer to adjust itself. I think that's maybe the key is we want to ask the user if they want this thing rather than assume. Just in the same way we're like, do you want night shift? Yes or no. When we set up our devices, we could start asking other questions like, oh, like, do you want this device to, you know, we notice you're holding your device really close. You want us to adjust the, you know, the font size or something like that. I think there's a lot of ways where technology can kind of become a little more automatic in sensing our own needs. So I think that's an interesting space and something that most companies are probably just starting to explore.
Question. Thank you, Sommer. Any other questions? Yeah.
Well, I've got kind of like a two-part question. It's probably unfair to unload it on you after this whole day, but I'm just thinking what's next in accessibility, like there's so many things we've done already, but do you see there's any sort of conditions or problems that we've yet to solve, or like what do you think is coming up? What can we do more for certain types of people? And then the other part is we're doing so many things to enable people to use technology in mobile devices and web and all kinds of things. Do you think there are cases where not using a mobile device, for example, is actually the best way to provide accessibility? Like, are there any things where like preventing the use of technology is the best for their lives?
Yeah. Short answer to the second half of your question is yes, which is obviously going to be very challenging for companies that make their money by selling devices. But I do think that helping people disengage from a device can be a form of cognitive accessibility. And I think we already are seeing that a little bit with screen time, for example, where we help users disengage a bit, help them monitor their usage. I also have noticed, you know, up and down, I'll see it kind of through my Twitter timeline, companies focusing on kind of the opposite of a smartphone, like a kind of an old style phone, like a phone that only does phone calls and nothing else, and only can handle text and phone calls and things like that. And the idea is to help people disengage from the constant stimulation that is in, you know, this device. So I do think that, kind of to your second question, there's really interesting work to be done there about how do we maybe help people disengage from technology when it might be healthier for them to do that. And I think that's an incredibly hard problem in capitalism in general. But I think it's a really important question. I know for me, actually, like I don't wear an Apple Watch anymore because it wasn't quite healthy for me. So it's very interesting. Oh my gosh, I already forgot about the first part of your question because it's still very early. What was the first part?
Well, the first part was basically what's next. Are there any conditions or problems we haven't yet solved or have discovered even? Like,
I mean, I wouldn't even argue that we've like solved the conditions we're currently focusing on. I think that there are a lot of apps, sadly, that aren't accessible. I think that there's so much space for apps to continue to be better, for platforms to continue to make it easier to make apps accessible or even more automatically do it. I think that we're just starting to see the exploration of AI and ML in the accessibility space with, for example, with sound recognition, which I mentioned earlier, like that's a really interesting example where we just got to the point where like we could run, good enough models on phones that a phone could sort of kind of substitute for ears in some cases and can help alert you to things to a tiny, tiny degree. And so I see technologies like that as just in like the earliest stages. And then as far as spaces we haven't fully explored yet, to me, the cognitive space is that space. Like it is, helping when I look at, like, for example, my grandma who recently passed, but like my grandma using her phone or her, like the iPad, there was so much for us to do to help, like as developers and as technologists, to help someone in her age group with her understanding of technology use technology. Like there was so much left. Like no matter how much I configured it, no matter how much I turned on large text and hid distractions, it was incredibly difficult. And so to me, I see like the aging space as just like a massive space we need to push ourselves because we are aging too. And I think that it's going to be really important to think about that space in particular.
Not a question you can definitely answer, but I'd be interested in your opinion, is do you think it likely that Apple, if not others, might start enforcing App Store rules to say, hey, you don't have dynamic text, you don't have, you fail accessibility in 80% or some margin rule that says, sorry, your app will be bumped from store if you don't comply. Do you think that's a trend that we might see happen? Would you be good?
Yeah, it's a hard, I think it's a hard problem that's getting maybe easier to solve via, I think a bit thanks to Swift UI and ways we can maybe more likely automatically detect stuff. Because like obviously the App Store review process is tough just as a problem of volume. And I'm sure Google has similar issues. So I could see that, like I think as the technology develops to like detect when maybe something is not correctly accessible or at least doesn't meet some kind of minimums, I think we could see that because I do see more regulation, more laws getting onto the books and more talk about what it legally means for something to be accessible. And that is increasing, we're seeing that more and more. So I think it's possible is the short answer. Yeah. Do I know when? Like, I know, but I think it's possible. And I would like to see it. I would like to see some more a higher bottom bar for apps to be available.
Any other questions? Nope. All right, thank you so much, Sommer. It's been an amazing talk, so thank you very much. I'd also like to thank all our speakers again for tuning in and presenting. It's been awesome. Wraps up everything. I don't think we have anything else.
Just a big round of applause to Aaron because without him tonight wouldn't have happened. You got some great speakers. Thank you to all the speakers.
So that's pretty much it. I think.
Yeah, that's it. We'll see you next month.
Yeah,
thanks
see you
everyone.
Next month. Did everyone get a pin before you go? Don't leave
it.
Okay. All right, well, next month, were we safety culture?
We are at safety culture. Yeah,
A week later.
a week later than normal. So the 4th Thursday. Yeah, it'll be here.
Thank you everyone for coming.